So let us talk about dark adaptation. Dark adaptation. Now suppose there is a person who was in a well lighted area, and suddenly he goes to area where there is no light or very less light or very dim light. What will happen? Initially he is unable to see, and after some time his eyes are adapted to that environment, to that dark environment, and he now he can see everything around him. So this is called dark adaptation. Why it takes time to adapt in a dark environment if we come from enlightened environment? It is because we need to decrease the threshold of the new photoreceptors to which they will respond. What is the threshold? Threshold means the minimum amount of stimulus or minimum amount of light that is required to excite those photoreceptors. Now, if we are in a lighted area, there is more light, so the threshold was more. But if we are in dark area, the photoreceptors should be more sensitive towards light. That means in less amount of light it should respond, so its threshold should decrease. And why it takes time to decrease the threshold? It takes time because we need to replenish the rhodopsin store. The rhodopsin stores were continuously degraded in lighted area, so we don't have those rhodopsins to respond to light in rod cells to respond toward less amount of light. So we need to replenish those rhodopsin stores. That's why dark adaptation takes time, and it all to fully adapting towards the dark environment, the maximum time that is needed is 20 minutes. Now what is light adaptation? If we come from dark to a lighted area, that our eyes can feel that the light was very much intense, and after some time we can see everything around us. This is called light adaptation, and it takes almost 5 minutes. In this light adaptation, the threshold of those photoreceptor, particularly rod cells, increases. Actually, this light adaptation is nothing but the disappearance of dark adaptation. Now this dark adaptation has two components. We know that we have two types of cell in our retina: dot cells and cone cells. Okay, cone cells are responsible for seeing in for the vision in bright light, and rod cells are responsible for scotopic vision or night light vision or vision in less amount of light. So when we are coming from a bright area or from a lighted area to a dark area, first cones adapt. Adaptation of cones is, what is adaptation? It's basically the decrease in threshold. So the adaptation of cones is very rapid, so their threshold decreases very rapidly, but this decrease in threshold is very less in amount. So threshold decreases very rapidly but in less amount, and after that this cone component is over, and now rod will decrease their thresholds so that we can see in dark. The decrease in threshold of these rod cells is in much more amount than these cone cells. Okay, So decrease in threshold of this rod cell is much more in amount, and due to this, but it is a bit slower than this decrease in threshold of cone. And finally, the final change between final change in the threshold between the light adapted and dark adapted eyes are very great. Now in the visual spectrum, there is violet in also 300 or 400 nanometer around, and red is around in the 700 nanometer, okay, in the visual spectrum. Now if somebody wears a red glass that filters lights, and somebody wears a red glass, then all the light passing through the glass will only contain red light, red wavelength light. So if somebody wears this red glass, he will see everything red, red, red. And also the property of rod cells are that they are not at all sensitive to these red lights. That means red light don't stimulate rod cells. If red light don't stimulate rod cell, if somebody wears this red glass and remains in the lighted area, their rhodopsin store is not decreased. They will have enough amount of rhodopsin store. So if he goes to a dark area, then his eyes will take much less time to adapt in that dark area. It will not take 20 minutes. Okay.